Our goal is to design a counter with mode control. It will cycle through the binary representation of decimal 0, 1, and 3. A manual mode switch will determine the direction of the sequence. When the mode is set to 1, it will count down, so 0, 3, 1, 0, 3, 1. When the mode is 0, it will count up, so 0, 1, 3, 0, 1, 3. It will also have an asynchronous clear switch that can force the state to 0 at any time, and it requires the use of T flip-flops. So here's the finite state machine chart. You can see the 3 states, 0, 1, and 3. You can see the binary representations of each state below. And you can see the 1s at the top and the 0s at the bottom, cycling through the states. 0 obviously counting it up, and 1 counting it down, going in a loop. And it's important to notice that the state for 1, 0 is missing because we will not be counting with 2, we'll be skipping it. These are the K-maps for the T flip-flops. As you can see, the rows are for M for 0 and 1, and the columns are for Q1 and Q0 in gray code. And we have our do not care conditions on the right side of both of these charts for 1, 0 because we're not using the value 2. Now remember, this is pretty important. For our K-map, we put 1 when that value is changing for T1, not when T1 is equal to 1 or T0 is equal to 1. We put 1 when it changes from 1 to 0 or from 0 to 1. And this is because we're using T flip-flops, not any other type of flip-flop. Because T flip-flops toggle, and that value is true when you want to change from one value to another, not when you're just having one value be equal to 1. The equations below are pretty self-explanatory. We just group all the 1s together and potentially our don't care conditions with the 1s. And we find the parts that don't change within the group and put that in our equation. You can notice that in our equation, the M prime and Q0 or M and Q0 prime acts the same as an XOR. That's the same with T0 equation. So those are both acting as XORs. And it's pretty apparent how these two equations can be put into circuitry. We just have the XOR ORed with Q1. And then for T0, it's the same situation, except we have Q1 prime and Q0 prime instead of just Q1. And of course the XOR being with Q1 instead of Q0. And now we just hook these up to our 2 T flip-flops, and now we have our final circuit. When we reset, it's going to be stuck at 0, and we can turn that off and it'll start counting. When mode is set to 0, it'll be counting upwards, so 0, 1, 3, 0, 1, 3. Then when I set mode to 1, it'll be doing the opposite, counting downwards, so 3, 1, 0, 3, 1, 0. And that is all for today. Thank you for watching.